Whoops. That's probably not big enough, huh? There we go. All right, so we're going to start with properties of congruence. Now, with congruence, we can't actually do any of the math. We can't do like the adding and subtracting. But there is a couple things that we can still do with congruence. Okay, we can still do our reflexive property, but this time it's of congruence. So, what did reflexive property of equality tell us?
Something is equal to itself.
Something's equal to itself. So this is the same idea, it's just that now something is, instead of equal, it's now congruent to itself. So like the measure, or angle 2 is congruent to angle 2. That's a bad congruent sign. So reflexive just tells us that something is congruent to itself. Okay, then we have our symmetric congruency, symmetric property of congruency. And what did symmetric tell us yesterday when we did it of equality with an equal sign?
Which one is the equal sign?
Yeah, we switch around that equal sign. So for symmetric here, we are going to switch it around, but it's going to be with congruency. So we might say like segment AB is congruent to segment CD. If we know that, how else could we write that? We know segment AB is congruent to CD. How else could we write that? We could write CD, start with that. CD is congruent to AB. That's just our symmetric. It's just flipping it around the congruent sign. We don't use that one too much. Okay, and then our last one with property of congruence is our transitive property of congruence. And our transitive property of congruence is really similar to our transitive property of equality. So let's just do angles because that can go a little bit faster. So if we know that angle 5 is congruent to angle 8, and we know angle 8 is congruent to angle 4. So we know 5, remember congruent? What does congruent mean? I should have started with that. Who's crazy? Me. What does congruent mean again? The same. They're the same shape, they're the same amount, same measure, they look exactly the same. It's like a copy and paste. So if 5 and 8 are exactly the same, and 8 and 4 are exactly the same, what do we know about all of them? They're all the same. So which two have we not said are the same yet?
5 and 4.
5 and 4. So we can say angle 5 is congruent to angle 4. So those are our properties of congruence. There's a couple other things we need to do before we start our proofs. We need two definitions, and then we need we need one theorem. Two definitions, one theorem. Okay, so this is going to be a definition of congruence. Now, right now, we're writing out that word congruence, but when we do this in proofs, we can just use the congruent symbol, that squiggly with the equal sign, without having to write out congruence. Okay, and we're going to do definition of congruence. There's two things we're going to say are congruent today. One is with segments. So definition of congruence of segments.
Can I go back standing tomorrow? Like, it's hot in here.
You'd have to add, I'm not sure what our COVID protocols are with airflow, to be honest. Okay, so if segments tells us that if two segments are congruent, then their measure is equal. So this is going to feel a little funny the way that we show it, but it's really just because of the formal part of the proof, the way that's presented and then given versus what we need to do with it. So for example, if we know that AB is congruent to CD, we could switch that. So instead of using the congruent sign, we would use the equal sign. But there is one little thing we have to tweak about it. How do I show the distance from A to B? What am I going to write to show distance from A to B? It looks almost the same, but there's one little difference. If you don't remember, go back to 1, 2 real quick. Flip where we write about distance. Look back all the way to 1, 2. How do we find distance between points? How do we write that? Like the third thing we wrote on that page on 1, 2.
With the line? With the arrow?
Close. So you had that AB, and then right underneath that AB, underneath line segment, we said measurement AB equals 5 feet, right?
Oh, what?
Remember right here?
Oh, move down for us.
Right there. That's our measurement. So what's the difference between the way we say it and the way we write the measurement? Like the line. We just don't use the line when we do measurement. Okay? So when we write this, if we know that segment AB is congruent to segment CD, we can say the measurement AB is equal to the measurement CD. Now we might say two segments are congruent. What other things are we dealing with today other than segments? Lines. We're going to deal with line segments. We're not going to deal with full lines. But we've also dealt with angles. So if we do this of angles, this means really similar. We just want to show it a little bit differently with angles. Okay, so if two angles are congruent, again, that means their measure is equal. So it's really similar to the definition of segments, congruent segments. Definition of congruent angles, what that's going to look like when we do it in our proof is if I know that angle 3 is congruent to angle 4. How we're going to rewrite that is by talking about the measurement. And when we do a measure of angle 3, remember we use that little m. Measure of angle 3. But instead of congruent, we're now going to say equals measure of angle 4. We're going to use that definition a lot for the next 2 weeks. We have one more theorem, and then we have some examples. Last theorem. This is a theorem that you know, but but it's just been a while since we talked about it. So this is a midpoint theorem. Okay, first off, let's draw out what that midpoint means. So midpoint, what are we dealing with with a midpoint? Are we dealing with an angle or a segment? A segment, so let's draw a segment. And how many points are going to be on the segment for the midpoint? 3. 2 at the end. Those are our endpoints. And where does the midpoint go? Directly in the middle. Okay, we just need to name those points for our theorem. This is just going to be a general statement. It doesn't mean it always has to be points, whatever we name them. What do we want the first point to be? A? And then? And then? You guys are so creative. A, B, and C. So a theorem is something that we can prove versus a definition gives us what is it. A theorem is something we can prove if we wanted to write a proof of it, which we aren't today, but maybe someday we will. What the midpoint theorem says is if point A, if point B is the midpoint of, what is it the midpoint of? Segment AC. So we're going to use that line, segment AC. If point B is the midpoint of AC, segment AC, and you already know this, then what do we know? Are congruent. Segment AB, the first part, is congruent to the second part, BC. Big thing here with the midpoint theorem is it says that they are congruent. It doesn't necessarily say that they're equal. We can say that they're equal, but that's going to be using what instead of the midpoint theorem? Yeah, what says that we can go from congruent to equal? Oh, there you go. Good job. Crushing it, guys. I can. All right, what you are going to do is we are going to do 2 problems on this paper that I handed out. You are going to cut it underneath the segments, but before you get to the angles. So you're going to cut it along this line or rip it or whatever, and then you can glue in this first part. I would hold off for the second part until we get to it. You are going to need space for this because we are going to do a 2-column proof. So I am going to go to my next page and glue it at the top of this page. If you'd rather not glue it and you want to copy it word for word and you want to draw the picture yourself, if that's going to just make your day, I mean, you could do that, but this is easier.
Why do we have multiple passes on to it? It makes sense. It's just going to be a big line.
All right. So paste that in. I'm going to go to my next page. Does anyone, if you need this written down, I'm going to leave that up for about 45 more seconds for any of this. And then I'm going to move on to the next page. The line. We're going to do the line one first. And then I would wait to paste in your angles because we might just have to see how many lines this takes up. It might take up 20, it might take up 5. We don't know. Alright, so on your next page, you should have that pasted in.